Hello, this will be a demonstration of Proposition 7 from Book 4 of Euclid's Elements, which requires us to, about a given circle, circumscribe a square. All we are given is a circle, A, B, C, D, like so. It's a circle, A, B, C, D. And the task at hand is to circumscribe a square about this given circle, A, B, C, D. We begin by drawing one diameter, the straight line AEC. We do this by finding the center first by 3, 1. Next, we join the straight line AE, like so, by postulate 1, and then we produce this downwards to point C by postulate 2. So we have something that looks like this. Now, at this point E, which is the center of the circle, we're going to draw another diameter, this one perpendicular to our original. So we're going to have the diameter BED, like so, BED, like so, right? So that all these angles here are going to be right angles, because we drew perpendicular by proposition 111. And then finally, at all these points on the circumference, A, B, C, and D, we're going to draw straight lines tangent to the circle by the porism of 316. So we're going to have the straight line FAG, like so, FAG. And then at the point B, we're obviously going to have the straight line GBH tangent to the circle at the point B. So, GBH. Next, at the point C, we're going to have the straight line HCK tangent to the circle ABCD at the point C. Like that. And then finally, at the point D, we're going to have the straight line FDK tangent to the circle at the point D. Right. Now, knowing that all these straight lines, which we have just drawn, are tangent to the circle, we know that the angles that they make with the diameters must be right angles. We know this by proposition 318. And so all the angles at A, at B, at C, and at D, these will all be right angles, again, by proposition 318. Now, knowing that the angles at E are right, so this would be to say that the angle E, other way around. We begin by saying that the angles at B, we know that these are right angles. So the angle EBG is a right angle. And we also know that the angle BEA is, the angle AEB is a right angle. And so these two angles here, EBG and AEB, these add up to two right angles, and these are co-interior angles. So these two straight lines, GH and AC, must be parallel by proposition 128, because they're co-interior angles, their interior angles on the same side add up to two right angles. Now we can prove in a similar manner that AC and FK are also perpendicular, because all the angles at E and all the angles at D are right angles, so they add up to two right angles, and so the straight lines must be parallel. So AC is parallel to FK. And now GK and FK are both parallel to the same straight line AC, and so by proposition 130, they must be parallel to each other. So GK parallel to AC, which is parallel to FK, which means that GK and FK are parallel. And then we can prove in a similar manner that all these straight lines GF, BD, and HK, these are also all parallel because their co-interior angles right here all add up to two right angles. Excuse me. Now, we know that AC right here is equal to BD because these are diameters of the same circle, and so by definition 115, they must be equal. And we know by proposition 134 that the opposite sides of parallelograms must be equal, which means that in the parallelograms GC and AK, we have their opposite sides equal. This would be to say that GH is equal to AC, right? Because these are opposite sides in the parallelogram GC. And similarly, that HC and FK, being opposite sides of the parallelogram AK, will be equal to each other. And so both GH and FK are equal to the same straight line AC. So by common notion 1, they're equal to each other. So GH is equal to FK. And in a similar manner, using proposition 134, we can say that the straight lines GF and HK are equal to each other because they are part of the, they're both equal to the same straight line BD, right? Because these are opposite sides of parallelograms. GF and BD are opposite sides, and BD and HK are opposite sides, so all of them are equal. So GF is equal to HK, and GH is also equal to FK. And we know originally that AC and BD must be equal to each other. They are diameters of the same circle. And so we can just common notion 1 everything together and say that GH and FK are equal to GF and HK, which means all 4 of these straight lines, FG, GH, HK, and KF, are equal to each other. And all being equal to each other, we know that the whole quadrilateral FGHK is equilateral. Now, next, to prove that this is square, we have to show that it's right angled, or at least we're going to presume that this is the square that we're looking for. So we have to prove that it's not only equilateral, but also that it's right angled, and this is fairly easy to do. We know that the opposite sides of parallelogram, or not only that the opposite sides of parallelograms are equal, but that the opposite angles will also be equal. That's another part of proposition 134. And so the angle AEB is equal to the angle BGA. And we know that all the angles at E must be right angles because we made the angles at E in that way. And so anything equal to an angle at E will also be a right angle. And this would mean that the angle here, AGB, is a right angle. Now we can prove in a similar manner using proposition 134 that the remaining angles at F, H, and at K, these will all be right angles as well, which means that the whole quadrilateral FGHK is not only equilateral, but it is also right angled, which means that by definition 122, this quadrilateral is in fact a square because it's equilateral and right angled. And we know by definition 4, which defines what it means for a figure to be circumscribed about a circle, all the straight line, or all the sides of this square FGHK touch the circle because we made them that way. And so this square FGHK has been circumscribed about the circle ABCD, which is what we set out to do. We set out to circumscribe a square about a given circle, and this being what we have just done, we are done with the proposition QEF. I have nothing to add to this proposition, so I will simply move on to proposition 4.8.